Welcome, and now I'm going to have a short introduction to the Pybytes using the Pybytes online interface for programming your picom device. So let's start. You have first you have to download the picom firmware updater, and that's pretty straightforward to do. You find it on the picom documentation homepage. If you haven't updated the expansion board, don't worry, you probably won't need to do it. It's only if you stumble into some problems during the way that you need to do that. So let's start the picom firmware updater app. Obviously I've already installed that one, and then go directly to the firmware update. And as you can see here while we wait, is that I have my LowPy 4, and I am just going to connect that one to USB. See, I can get it right. Now it's connected. Let's go directly back here, and we can see that the picom firmware updater is started. And then it looks like this. I get a welcome wizard. It's just checking for the latest version and well, anonymous usage statistics. Well, let's go with that. And the development releases. Let's take continue. And it just says that, oh, please close whatever other programs you have in the background that might interfere with your flashing firmware. And I'm just going to close my atom. So, good thing it reminded me. Let's press continue, and it seems that it has found my picom device right away. What we're going to do now is to choose which firmware we're going to update with, and I'm going to choose Pybytes. We'll talk more about firmwares later on, and you always have the ability to flash from a local file if you want to have specific firmware. More can be found on their GitHub. And I'm going to check this, force update Pybytes registration. I'll show you why. I'll now go and log into Pybytes. And Pybytes, you just go into the address pybytes.pycom.io. You'll find that you need to register an account. It's free, just register an account. And after that, we are going to provision this device just using the Pybytes library. And in this session, I'm going to show how to do it via USB. Before I start provisioning my device, it's a good thing that we configure networks. I've already pre-configured a network. So at first, you should start with Wi-Fi. You won't get the interactive functionality using LoRa or Sigfox. So just add Wi-Fi and your Wi-Fi password. It's as easy as that. As you can see here, I have my Wi-Fi already configured, the Woods family. And let's go back to getting started. Add a device via USB. Then you have to choose which device you're going to be working with. Let's use the LowPy 4 because that's the one I have. Enable networks. You need to enable some networks in order to communicate with the device. For this example, just click in Wi-Fi. We'll cover LoRa and Sigfox later on. And in this example, I don't even have the option to choose LTE, as this is a low Pi 4 which doesn't have that band. And I'll just press next, then customize your device. You'll get a suggestion of a nice name. It always comes up very nice name. Good work there, Pycom. Regal Jellyfish, perfect name. I couldn't have done it better myself. And then which Wi-Fi I want to use, and I'll just press save. Okay, I've created a new device in my Pybytes platform. This device is not yet connected. I haven't provisioned this device down to my low Pi device just yet. And you can see here, last connection, never connection, and firmware unknown. So this is an empty device at this moment. But you see here, activate your device with the firmware updater. You can do it with the firmware updater, and you can do it with the PyMaker plugin. Both are easy. We'll just cover the firmware updater. You'll get the new firmware and activate it right away, and that makes sense. So I'll just copy this. Oh yeah. Let's go back to the firmware updater. And as you see, I check this box, force update Pybytes registration. Continue. It's reading information about the board. And then I'll just paste this information, the picom activation token. And as you can see, something happened in the background here. So now I'm starting the process of provisioning this device. And just choose here, it should be done when it reads the board, but it's a low Pi 4, Pybytes, and I choose the newest firmware. File system, well, they changed to little file system a while ago, but it shouldn't matter that much. And just to be sure that I have no old files lying around on my board, I erased during update. And the LoRa region should for all of you be European Union. Actually for me now it should be the US 915, but I'm not going to use LoRa in this example anyway. Depends on where you are in the world. And let's flash the device. So now I have this in a fast communication mode, so it shouldn't take very much time. And what it does now is that it's downloading the firmware from the Pycom server on the internet, and it's just flashing that onto the Pycom board, the low Pi. And I should be up running in just a moment. Let's see how this goes. And just to mention that there are different versions of this firmware. So depending on that, some of these firmware versions does not contain all the MicroPython libraries and vice versa. If you, for instance, install the legacy firmware, you might miss out of some of the Pybytes libraries which are included in this Pybytes version. But more or less they should be pretty similar for the base set of functions. But this firmware, that's if you're going to work with the Pybytes platform, which is a good start. Just to mention here, when you now have flashed your device, this comes up regardless of if you have flashed a Pybytes firmware or just a legacy firmware, is that you get some information about your low Pi device. You get the device ID, LoRa MAC, Sigfox ID, and Sigfox PAC. Sigfox ID and PAC is going to be needed if you want to use the Sigfox backend. We'll dive into that as one special lecture later on, session later on. The LoRa MAC, that's very easy to just display in the terminal later on. But just to make it easy, I usually recommend just open the text editor and copy this in. and then just save it in your project folder or whatever, and you have it handy later on. You will need the LoRa Mac if you manually want to add your device to the TTN server. But no worries for this, you can just close this, no information is lost, it's just a matter of convenience. Okay, my device is now provisioned, and as you can see here in the background, last connection 2 minutes ago, and it also displays the firmware version. I have my first dashboard, and I can see that I have some data received. So at 12:40 I received 6 bytes from this, and I'm not at this moment sending any signals. I haven't connected anything to it. This is, as you see, a pretty easy way to just provision your device. And this now I'm just going to show you how you can communicate with the device very fast and very easy and very convenient without even using your Atom or Visual Studio Code or PyMaker. They have now, since just a month ago, a new PyMaker online application on the Pybytes platform. So please note that I'm still in my device. Then I can open PyMaker, and now it's connecting to the platform, and I can actually just put code right away and upload it to the device without even being close to the device. This could work anywhere. So this is a very neat way, and we will cover that later on. But what you could do is to update firmware for a lot of devices using the project function. So if you have 10 devices using the same code, you can provision new code, new updates to all of them very easy. But let's just see if we can get something running on this device. And as I've not connected anything to it, let's make it as easy as possible. I'll just use the RGB LED as my indicator if there is something happening on board. So you should actually never copy paste like I'm doing now. I wouldn't recommend it. Try to write your code directly and manually. Let's go back to the Pybytes platform, and you can see here that I have the boot.py and the main.py and the pybytes config.json. The pybytes config that contains information about the Wi-Fi networks, for instance, it's stored in plain text. So I won't open that just now because you'll see my Wi-Fi password. Well, if someone would care anyway. But let's just import this code here, which I copied from the RGB example. And as you see, I first import the pycom library, import the time library just to make a sleep function. I turn off the heartbeat. As you see now, there is a blue LED blinking every, I think it's 4 seconds, just to show that well, the device is running. And then it's just a cycle here: green, yellow, red, and it sleeps a little in between. So 5 seconds, 1.5 seconds, and 4 seconds, and then it's just doing that over and over again in 10 cycles, and then it will turn itself off. Let's see what happens if I press save and upload. Oh, very exciting. File synchronized, and please check the LED light on the pycom device now, and we'll see what happens. It's still blinking blue. There is, oh, green light. You can see now green, and this is supposed to be red, and well, green again. So it seems that I've now uploaded a code snippet to my LowPy 4 without even connecting it to USB. Well, it's connected to USB, but that's only for power in this case, and for the firmware updater. But the code is sent over Wi-Fi from the Pybytes platform. So this is one way of doing it. If you would like to start up pretty easy, and if you don't get it to work, you could do a lot of things directly in the web browser. I would not recommend this way. It's more of a nice way of doing it as well, as I see it. You need to, in first hand, get your head around how Atom works. If you work with Atom, you'll get the PyMaker plugin, and then you have the REPL interface just down below, which is much easier. You'll have a direct feedback to your terminal, and you can see what happens, and you don't get the same debug code and feedback if you use the Pybytes online editor. So this is absolutely the recommended way when you're playing around, but you can get up things going pretty quick if you just use the Pybytes library. This was just the basic start of the Pybytes platform. More will come.